Okay, so good evening or good afternoon. So our topic for today is all about integration of trigonometric functions. Okay, so by integral calculus. Okay, so our objective for this lesson is to solve different problems in integration, so which involves trigonometric functions. So we have here some integration formulas that we can use for us to integrate uh, trigonometric functions. Okay, so we have here the integral of cosine x dx, which is sine x plus c, to the integral of sine x, which is with respect to x is negative cosine x plus c. Okay, so it's negative counterpart. So integral of negative cosine x, that's negative sine x plus c, and the integral of negative sine x, which is cosine x plus c. Okay, so here are some trigonometric functions. Okay, so integration of two functions. Okay, so let's start with our first example. So let's say we're going to integrate in a cosine of 2x dx. Okay, so for us to integrate this, okay, we let you. So we're going to do u substitution here. So we let u as 2x, then we get its derivative, which is equal to 2 dx. But of course, our function is dx in terms of dx. So we can say that dx is by division property of equality, that's du. Okay, so after everything, so we're going to substitute it in the formula. Okay, so this will be the integral, okay, of cosine of u, then of course du over 2. Okay, so we have 1/2 here, so we're going to replace the constant 1/2 on the outside of on the outside of your integral sign. Okay, so this will be okay. This will be 1/2. Okay, then integral. Okay, then cosine of u du. Okay, so the integral of cosine u is therefore 1/2 will multiply by sine u plus c. However, our u, so we're not done with integration since we're done with the substitution. So we're going to replace back the u by 2x. So this will be 1/2 sine 2x. So this will be the answer for our first example. Okay. Questions for this example? Okay, let's proceed. Okay, we're going to integrate sine 3x plus 5dx. Okay, so like we did in our first example, we're going to do the substitution. So we have u, which is equal to 5. Okay, so the angle. So we're going to get the derivative of the angle, so which is equal to 3 dx. Okay, however, our function is dx. To express this du equals to 3dx in terms of dx only by using division property, divide both sides of the equation by 3. So this will be dx, which is equal to du. Okay, so let's proceed. So we integrate. Okay, so we integrate sine u multiplied, of course, by du over 3. Okay, so since we have a constant of 1/3 in our function, so we have to replace it outside of the integral sign because the constant is not part of the derivative. So 1/3, we have 1/3 the integral of course, sine u. First, the integral of sine of u, which is equal to 1/3 multiplied by negative cosine of u. C. Of course, this will be equal to negative 1/3 by cosine of u plus c. Okay, however, we're not done yet because we only did the substitution. So we're going to replace back the value of u, which is 3x plus 5. So your equation now, this will be, or your function, this will be negative 1/3 multiplied by cosine of 3x plus c. So this will be the answer for your particular problem. Questions? Okay, so let's proceed. Okay, in our example here, we're going to integrate sine raised to the third power x dx. So since even though it's a transformation of trigonometric integral, so since this is a trigonometric function, okay. In this case, integrate sine cube x. Okay. So since by laws of exponents, we remember the product rule for exponents a raised to m and a raised to m, which is equal to a raised to m plus n. So in this case, we're going to use this in separating the exponent. So this will become, okay, so the integral of, okay, so this will be sine squared x then sine of x. Okay, so this will be your function. However, we can integrate sine x dx because that's negative cosine x plus c. But since you have sine squared x, so we're going to use trigonometric identity. So we're going to use Pythagorean identities. So we remember that sine squared x plus cosine squared x, which is always equal to 1. Okay. However, in your function, the given is sine squared x only. So since that's the problem, we're gonna use subtraction property, subtracting cosine squared x to both sides of the equation. So this will be sine squared x equal to 1 minus cosine squared of x. Okay, so this is the function that we're going to use for this trigonometric integral. Okay, so this will be integral of, okay, 1 minus cosine squared of x sine x dx. Okay, Since we have a grouping symbol here, we're gonna use distributive property to distribute the integral side and the sine x dx to all the terms inside the parentheses. So because we want to remove the grouping symbols using distribution or distributive property of equality. So this will be, okay, so this will be the integral of cosine squared x minus, okay, the integral of sine of x dx. So in this case, we all know that cosine squared x is also the same as cosine x squared. Remember, by using the product rule, the exponent rule for exponents, that such that a raised to m, which is also raised to n, is equal to a raised to of n. Okay, we don't forget to remember this. Take note of this law because it's very useful, especially for integration of trigonometric powers. Okay, so this will be cosine x then squared. Okay, so we let you as cosine of x get its derivative, which is equal to negative sine x. Okay. So since there is a negative here, so we're going to do the substitution. So this will be, okay. So the integral of u squared multiplied by, of course, negative du. Okay, of course we don't want the negative sign inside that integral. Okay, minus integral of, or we can integrate this, the integral of minus integral of sine x, that's negative cosine, so negative of negative, that's positive cosine of x. So we will place the negative sign outside the integral, so because like a constant, that's part of the derivative process. Okay, so negative integral of, okay, u squared du, the plus cosine. Okay, so in this case, we are gonna use the power formula for integration. Okay, so we remember that the power formula for integration is, okay, the integral of u raised to n u, which is equal to, okay, u raised to n plus 1, okay, over n plus 1, then plus c. Of course, n is not equal to negative 1. Okay, n is not equal to negative 1. Okay, so that's the formula for we're gonna use for this one. Okay, so this will be, the equation will look like this, which is equal to, okay, u raised to 2 plus 1, or u raised to 3, and over 3, and plus cosine x. However, since we did u substitution, we're gonna replace the u by its original function, which is equal to cosine x. So this will be, cosine cube over 3 plus cosine x. Okay, so this will be our answer for this particular problem. Actually, that's negative u cube. We forgot the negative sign. Okay, the answer is negative cosine cube x over 3 plus cosine x plus 6. Okay. Do you have any questions with our example? Okay, let's proceed. Okay, so this is simple integral of tangent x dx. Okay. Okay, so the integral of tangent x is equal to ln, or it's negative ln cosine with the ln of second x plus c, or that's also equal to negative ln of cosine x c. Okay, so let's see how this happened. Okay, so we can derive how did it became ln of second. Okay, so integral of tangent x dx, which is equal, we can manipulate this, okay, by using this. We can also say that second x tangent x over second x then dx. Okay, so we can also say that the numerator is second x tangent x dx, and your denominator is second x. So if we're going to let u, which is equal to second x, if we get its derivative, that's second x tangent x. Okay, so that's your numerator. So we remember that the integral of du over u just the ln of u plus c. Okay. In this case, this will be ln of second x plus c. Okay. So that's one good point. Okay, this is one derivation. Okay. How about how did it became negative ln of cosine x? Okay. We remember in our trigonometric identities that second x is reciprocal of cosine x. Okay. In this case, we can also say that this ln is ln of 1 over cosine x plus c, right? And also, if we're going to use the reciprocal rule for exponents, remember that a raised to negative n is just 1 over a raised to n. Okay, so we can also say that this 1 over cosine x plus c is also the same as ln of cosine of negative 1. Okay, so this is a natural log. So in based from the logarithmic identities, we remember that uh, log of m raised to n, which is also equal to n log of n. We can say that this negative 1 here, we will put this down here using this formula. So we'll put the negative sign here, the negative 1. So this will be negative ln of cosine. So using this formula, okay. Do you have any questions with our example, fourth example? Okay, so let's proceed. Okay, for this one, you're going to integrate tangent squared x. So the integral, so we're gonna use trigonometric identities. So tangent squared x. I'm gonna rewrite the function. Okay. So let's derive the formula that we're going to use. So this from the Pythagorean identity, the sine squared x cosine squared x, which is equal to 1. And if we're going to divide, if we're going to divide this by sine or by cosine squared, okay. So we divide this equation by cosine squared x, okay. Okay, so this will become, so sine squared x over cosine squared x is also the same as tangent squared x plus cosine squared x divided by cosine squared x, that's equal to 1, which is equal to 1 over cosine squared x, cosine squared x is secant squared x. Okay, so since since this will be the formula that we're going to use from this tangent squared x. So it's also it's only indicated that's tangent squared x. Okay, let me erase this. So this will be tangent squared x. Okay, so this will be, so we're going to subtract 1 to both sides of the equation. So this will be tangent squared x. The second squared x minus 1. Okay, so which means this trigonometric identity we're going to use in tangent squared x. So this will be the integral of, so this will be secant squared x minus 1. Okay, so again, so we have a grouping symbol. So we need to distribute this integral sign and this dx to all the terms inside the parentheses. So to eliminate the grouping symbol using distributive property, so this will be the integral of, okay, so this is secant squared x dx, of course, minus, okay, the integral of dx. So of course, so the integral of the secant squared x dx based on our formula, that's tangent, minus the integral of dx based from our basic integration formulas. So this will be minus minus x. And don't forget to add c to denote that we have finished integrating the trigonometry function. Okay. So the answer for our problem here is tangent x minus x plus c. Okay. Do you have any questions with our fifth example? Okay, let's proceed. Okay, so I think we have 7 problems. So we have the integral of tangent cube x dx. Okay, so same procedure for tangent squared x. The only difference is that we have an exponent of 3. Okay, so this will be tangent of, Okay, this is the integral of tangent cube. Of course, we're going to evaluate this. We're going to expand this for us to simplify our integral. Okay. So based from our definition of loss exponent, so this will be the product rule of exponents. So this will be tangent squared x. Then this will be tangent x. Yes. Okay. We can easily integrate tangent x, right? Because that's only ln of secant x plus c or negative ln of cosine x plus c. So for tangent squared, we're going to use trigonometric identity, and that is, so tangent squared x, we remember that the identity of this tangent squared x is secant squared. Okay. We're going to replace this secant squared x minus 1 here in tangent squared x. So this will be the secant squared x 1, and then of course don't forget the tangent x. Okay, so based on this equation function, we're going to distribute the integral sign and the tangent x dx to all the terms inside the parentheses. So this will be integral of secant squared x tangent minus integral of tangent x. Okay, in this case, we're gonna use the substitution for tangent x and the du. So the derivative tangent x is secant squared. Okay. For tangent x, we have already discussed our answers now, so it can be a negative ln of secant x. Let's see, or negative ln of. Let's see. Okay, so this will be okay. So this will be u times du. Okay, then minus the integral of, or we can say that this is at negative ln. Okay, so this will be u squared over 2 plus ln of cosine x. So we're done integrating. No, we're gonna replace the u. So our u a while ago was tangent x. So this will be just 1/2 tangent squared x plus ln of cosine x. Yes. Okay, so in this case, this will be our answer for this particular problem. Okay. Do you have any questions with our sixth example? Okay. Let's proceed with our last example. Integrate. So this one is a little is easier than the previous examples. Integrate sine 4 of x dx. So we're gonna use substitution here. So we're gonna use u for x. we're gonna get the derivative of u, which is the angle, which is 4. Okay. So based on this example, that's only dx. So this is for dx. We're gonna divide both sides of equation by 4. Okay, so dx is d over 4. Okay, now we proceed with integration. Okay, so this will be the integral of sine u multiplied by du over 4. Okay, however, we have a fraction here, so we need to put the fraction outside of the integral sign because again, that's not part of the derivative. So the 1/4 here, integrate of sine u okay, so the integral of sine u is 1/4 multiplied by negative cosine of u. However, we need to put the negative sign on the leftmost part of your equation. So this will be negative 1/4 cos multiplied by cosine of u. Let's see. Are we finished? No, because we're gonna replace u by back to 4x. So this will be negative 1/4 times cosine of 4x. Okay, so this is our answer for this particular problem. So that's negative 1/4 of cosine 4x plus c. Okay, do you have any questions? May nakamute. Okay. Okay, so let's proceed. Let's proceed. Let's check our understanding. So we're going to evaluate the following integrals. Okay. So if you need more time, just have to pause the video. Okay, so let's check. Okay, let's evaluate your answers for this one. For number one, so the integral of cosine x dx. This is easier to integrate, so that's only sine x plus c. Okay. Next, the integral of negative 5 sine of x dx. Also, this one is also easier to integrate because this is also this is 5 cosine of x. Okay. Okay. So for number 3, we have this one is easier to integrate. The answer for this one is 3 tangent of x. Okay, let's go to number 4. Okay, so tangent of 4. So let's answer this. The integral of tangent. Okay, so this is also the same as squared x multiplied by tangent squared x. Okay, so remember in our previous examples, we have our equivalent identity for tangent squared x. which is equal to secant squared x minus 1. Okay, so let's go back to our exam problem. Okay, so this will be okay. So this will be okay, the integral of squared minus 1. Of course, we tangent squared. Yes. Okay, we use distributive property. So this will be okay. This will be secant squared x tangent squared x minus the integral of tangent squared x. Okay. So we have here another tangent squared x. So we're gonna replace this another by this identity. Okay, so this will be, we don't forget the dx here. Okay, so we have the secant squared x tangent squared x minus the integral of course the secant squared. Okay, we don't forget to add the s here. Okay, so distribute. This will be okay. So this will be secant squared x tangent squared x minus the integral secant squared x dx and plus integral of dx. Okay, so our answer for this particular problem, so this will be 1/3 of tangent cube x minus tangent of x. So this will be our answer for this problem. Okay, so we will put the answer. So this will be 1/3 tangent of cube of x tangent. Okay, next we proceed. Last problem. We have here sine fifth this will be, if we're going to separate this, so this will be the integral of cube sine. Okay, so we cannot integrate sine cube of x, but we can integrate sine squared x using trigonometric identity. Okay, so this will be, so remember that in our Pythagorean identity, the sine squared x of sine squared of x equal to 1. Okay, so since this is a sine squared x, so this will be sine squared x subtract cosine squared x to both sides of the equation. So this will be 1 minus cosine x. So this will be integral of sine cube of x. Okay, so sine cube of x multiplied by 1 minus cosine squared of x will be x. Okay, so we're gonna use the distribution property of equality or distributive property of equality. So this will be the integral of sine cube x minus the integral of cube sine. Okay, so in this case, sine cube x, you cannot integrate this directly, but we can, however, expand this to simplify the equation. So this will be okay. So sine squared x and sine of x dx minus. So we're gonna do also the same for sine cube of x here on the other term. So this will be sine squared x sine x cosine squared x. Okay. So again, we're gonna replace this sine squared x here by this trigonometric identity 1 minus cosine squared x. Okay, so this will be integral of 1 minus cosine squared of x dx minus, okay, so this will be 1 minus cosine squared and cosine squared. Okay, so this will be a longer equation. Okay, so this will be using distributive property, eliminate the grouping symbol at the first term of your integral. So this will be integral of sin x dx. And of course, this is equal to integrate now minus cosine squared of x minus, okay, sin x cosine squared x dx or cosine squared x sin then plus the integral of cosine the fourth of x. Cosine x dx. Okay, so simplifying this equation, the answer for this equation, this will be cosine of x minus 2/3 cosine of cube x. Okay, so plus 1/5 of cosine plus c. So this would be the answer for number 4. Okay, do you have any questions? Okay, so if you have no more questions, then I will see you on our next lesson.